Hey everybody, Happy New Year to you all. So this is AutoStreamer is like my big project for the new year, started with anyway. So like as it says in the title, this is my attempt to automate myself out of my own videos. Let's see how it goes. It's going to look like this. And essentially it's capable of creating a curriculum. We're going to run the Python curriculum. Do let me know if you have any issues with the audio, by the way. But we're going to run the Python curriculum. And it's actually good with any kind of programming content, also with math. It explains everything in code. So if we were to run the calculus curriculum, it'll actually generate the calculus formulas in Python code. It can also do JavaScript, but since it uses HTML to display the content, it can be a little bit difficult. So this is a special project for me. I'm going to start it and not talk during the live stream. I do have this up as my Patreon shop. If you like it, you can download it. It's $200 for the first 50 purchases. But let me just run it. See, I'll be on the chat, by the way. If you have any questions, I'll be talking. Marcos, thank you very much. I appreciate it. Happy New Year to you, to all of you. So all we have to do is just run. If nothing goes wrong, this should work. Yeah, it lists all the curriculums from the curriculum folder. I'm going to select 5 for Python. And it actually uses a queue system, so it doesn't generate all the content right away. So it is a truly real-time system. She should start speaking shortly. Link for the Patreon is in the description, by the way. If you do download it, you can modify all this to suit your purposes.
History of Python.
So it started, I hope you can hear it.
Language known for its readability and versatile nature. It was created by Guido van Rossum and first released in 1991. The concept of Python was conceived in the late 1980s, and implementation began in December 1989. Guido van Rossum, the creator, named it after the British comedy group Monty Python. The first public release, Python 1.0, arrived in January 1994. Significant updates were Python 2.0 in 2000, which introduced list comprehensions and a garbage collection system, and Python 3.0 in 2008, which was a major revision designed to rectify fundamental design flaws. Python 2 was sunsetted in 2020, with Python 3 now being the standard. Features of Python. Python is an interpreted language, which means that it executes the code line by line. This feature facilitates debugging, as errors are reported as soon as they are encountered. The provided code attempts to print "Hello World" and then divide 1 by 0, which will cause a 0 division error. Because Python is interpreted, it will print "Hello World" successfully, but then stop at the error, demonstrating the immediate execution behavior. Python installation and environment setup. To get started with Python, you need to install it on your computer. Python can be downloaded from the official website. After installation, setting up a virtual environment is a good practice, especially for managing project-specific dependencies. There is no code to demonstrate the installation of Python and environment setup, as it largely involves download and execution of installers and command line instructions. The process typically involves downloading the appropriate Python installer for your operating system from https://python.org/download/, running the installer, and then creating a virtual environment using the venv module, which comes bundled with Python 3 to create an isolated environment for your Python projects. You can do this by running a command like python3-mvenv/path/new virtual/environment in your terminal. Running Python code. Running Python code can be done in different environments, such as an integrated development environment, IDE, command line interface, or through a notebook interface. We'll look at running a simple Python script using the command line. The code is using the print function to send the text "Hello Python" to the console. When this line is executed in a Python script, it results in displaying the message in the command line or shell, where the Python interpreter was called. Basic syntax. In Python, comments are used to explain what the code is supposed to do. They are ignored by the interpreter and do not affect the execution of the program. The hash symbol denotes the beginning of a comment. Any text following this symbol on the same line is considered part of the comment. Python keywords and identifiers. Keywords in Python are reserved words that cannot be used as variable names, function names, or any other identifiers. They define the syntax and structure of the Python language. Since Python keywords are the fundamental building blocks of the language, they have special meanings attached to them and are a core part of the Python syntax. They help define the language's rules and are essential for parsing the code. Examples include if, for, while, class, return, and so on. To view all keywords, you can use import keyword print keyword.kwlist. These words cannot be used as identifiers. Doing so will result in a syntax error. Python comments. Comments in Python are used to explain the code, make it more readable, and prevent execution of code when testing. There are two types of comments in Python: single-line comments and multi-line or block comments. The single-line comment starts with a hashtag and extends to the end of the line. The multi-line comment is enclosed within triple quotes, or. The interpreter ignores comments, meaning they are not executed as code. Inline comments are placed on the same line as a statement to clarify what that specific line of code does. Variables and assignment statements. In Python, variables are names attached to values and do not need explicit declaration to reserve memory space. An assignment statement creates a new variable and gives it a value. The equal sign equals is used to write an assignment statement. Here, x is a variable that is assigned the value 10. Then, another variable y is created and assigned the value of x plus 5, which calculates to 15. Finally, print y outputs the value of y to the console. Standard data types: int, float, star, bool. Python has several standard data types that are used to define the kind of value that tells what operations can be performed on a particular piece of data. The basic data types in Python include integers, int, floating point numbers, float, strings, star, and boolean, bool. The code defines 4 variables, each representing a standard Python data type. Integer is of type int, representing whole numbers. Float num is of type float, representing numbers with a decimal point. String is of type str, containing a sequence of characters. Boolean is of type bool, representing true or false values. Data type conversion. In Python, data type conversion, also known as typecasting, is the process of converting the value of one data type, integer, string, float, etc., to another. This is useful when you need to perform operations that require a certain type of input, or when you have to ensure that data types are consistent across your program. The built-in functions like int, stir, float, and bool are commonly used for type conversion. In the provided code, stir from int converts an integer to a string using star. Int from star converts a string to an integer using int. Float from star converts a string to a float using float. Bool from int converts an integer to a boolean using bool. When an integer is 0, it converts to false, otherwise to true. Dynamic typing. Dynamic typing means that variables in Python are not explicitly tied to a specific data type. A variable that was used to store a particular data type can be reassigned to hold a different type of data at any time during execution. This is different from statically typed languages, where the data type of a variable is declared and cannot change. In this example, we assign an integer to x. Then we reassign a string to the same variable x. And finally, we reassign a float to x. Each time, we print out the type of x using the type function, demonstrating that the type of x can change dynamically. Mutable versus immutable objects. In Python, objects can be either mutable or immutable. Mutable objects can be changed after creation, while immutable objects cannot. Understanding which types of objects are mutable or immutable is crucial for programming effectively in Python, especially when dealing with data that can change over time or should remain constant. In the code, an attempt to modify an immutable string results in a type error, showcasing that strings in Python are immutable. On the other hand, assigning a new value to the first element of the list successfully changes the list, indicating that lists are mutable. Immutable types include int, float, bool, string, tuple, and frozen set. Mutable types include list, dict, set, and objects of custom classes, unless specifically made immutable. None. In Python, none is a special constant that represents the idea of nothing or no value here. It is its own data type, none type, and is often used to signify the absence of a value or a null reference. This code initializes a variable x with the value none, which means it has no value. The if statement checks if x is none using the is operator, which is used to compare with none. If this condition is true, it prints x is none, otherwise it prints x is not none. The output of this code will be x is none because x was indeed set to none. Naming conventions. In Python, naming conventions are a set of rules for choosing the character sequence to be used for identifiers, which denote variables, functions, classes, modules, and other objects. Following these conventions improves code readability and maintainability. The code snippet demonstrates several naming conventions. My example class follows the capwords convention used for classes. The moneinit method is a special method named with double underscores. My attribute is a variable in lowercase with words separated by underscores, following the snake case convention used for variables and functions. My function is a function name that also follows snake case. Constant value is in all uppercase with underscores separating words, indicating it is a constant. These conventions enhance the clarity of which kind of entity each name represents. Arithmetic operators. In Python, arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication, and so on. These operators can be applied to numbers to carry out basic arithmetic. In the provided code, a and b are numbers on which we perform operations. C gets the result of adding a and b. D stores the difference. E is the product of a and b. F is the division result. G is the remainder when a is divided by b. H is a, raised to the power of b. I gives the result of floor division, which is division followed by rounding down to the nearest integer. Comparison relational operators. In Python, comparison relational operators are used to compare two values. The operators include less than, greater than, less than or equal to, equals, greater than or equal to, equal to, and equals, not equal to. These operators evaluate to a Boolean value, true or false. The code compares two integer values, a and b, using different comparison operators and prints the result of each comparison. First, it checks if a is less than b, true. Then if a is greater than b, false. If a is less than or equal to 10, true. If b is greater than or equal to 10, true. If a is equal to b, false. And finally, if a is not equal to b, true. Logical operators. Logical operators in Python are used to perform logical operations on the values of variables. The result is always a Boolean value, either true or false. There are three main logical operators, and, or, and not. The and operator returns true if both operands are true, the or operator returns true if at least one operand is true, and the not operator returns true if the operand is false. In this code, we declare three variables a, b, and c with values 25, 75, and 100, respectively. We then use logical operators to evaluate expressions. Result AND uses the AND operator to check if both a and b are less than 100, which they are, so it returns true. Result OR uses the OR operator to check if at least one of a or c is less than 100. Since a is less than 100, it returns true. Result NOT uses the NOT operator to inverse the truth value of C100, which is false, so it returns true. Bitwise operators. The bitwise AND operator AN performs a bitwise AND operation on two integers. It returns a number where only the bits that are 1 in both original numbers are also 1 in the result. In the binary representations, 12 is 100 and 5 is 0101. The AND operation results in 0100, which is 4 in decimal. Assignment operators. Assignment operators are used in Python to assign values to variables. The basic assignment operator is equals, which assigns the value on its right to the variable on its left. There are also compound assignment operators that combine an arithmetic operation with assignment. Each line in the provided code uses a different assignment operator. The variable x starts with the value 10. The plus equals, nanisk equals, stools, slash equals, sen equals, and slash like equals are compound assignment operators that respectively add, subtract, multiply, divide, modulo, raise to power, and floor divide the value of x by the value of y, and then reassign the result to x. For instance, x equals y is equivalent to x equals x plus y, which would result in x being 15 after this line is executed. Identity operators. In Python, identity operators are used to determine whether two variables reference the same object in memory. The two identity operators is and is not. The code defines three lists, where A and B reference the same list in memory, while C is a new list with the same values. The is operator checks if A and B refer to the same object, returns true, and if A and C refer to the same object, returns false. The is not operator checks if A and C do not refer to the same object, returns true. Membership operators. Membership operators in Python are used to test whether a value or variable is found in a sequence, string, list, tuple, set, and dictionary. The two membership operators are in and not in. They return a Boolean value, indicating whether an element is present or not in the given sequence. In the provided code, we first define a list_my_list with integers 1, 2, 3, and a string apple. We then use the in operator to check if the integer 2 is present in my list, which should return true, because 2 is indeed an element of the list. After that, we use the not in operator to check if the string banana is not present in my list, which should return true because banana is not an element of the list. Operator precedence. In Python, operator precedence refers to the order in which operations are evaluated when an expression has multiple operators. For instance, multiplication and division have higher precedence over addition and subtraction, which means they will be executed first. Understanding operator precedence is important to ensure the correctness of expressions. In this expression, the operator with the highest precedence is store, exponentiation, so 3 + 2 is evaluated first, resulting in 9. Next, the multiplication and division are of equal precedence, so 2 9 is evaluated to get 18, which is then divided by 6, resulting in 3, according to the left-to-right ordering. Finally, addition and subtraction are evaluated in left-to-right order, so 10 + 3 is 13, and 13 - 5 is 8. Thus, result is assigned the value of 8. If statement. The if statement in Python is used for decision-making operations. It tests a condition and executes a block of code if the condition is true. Here's a simple example to demonstrate its usage. In the provided code, we have a condition that checks if the variable number is greater than 10. If this condition evaluates to true, the code inside the indented block will execute, and number is greater than 10 will be printed. If the condition is false, the code inside the block will be skipped. If-else statement. The if-else statement in Python is used for decision-making operations. It allows the execution of a block of code when a specific condition is met, if block, and another block when the condition is not met, else block. In this code, we check whether the variable value is greater than 10. If it is, we print value is greater than 10. If value is not greater than 10, which is the case here since value equals 10, the else block is executed, and we print value is not greater than 10. If-elif-else chain. An if-elif-else chain in Python is used to test multiple conditions in a sequence. The if evaluates a condition, and if true, the subsequent block is executed. If it's false, the elif, short for else if, statements are checked in order until one is found to be true. If none of the conditions are met, the else block is executed as a default case. In this code snippet, we have a variable a with a value of 20. The if-elif-else chain first checks if a is less than 10, which is false. The elif then checks if a is less than 20, which is also false. Since neither condition is true, the else block is executed, resulting in the output a is 20 or more. Nested if statements. In Python, nested if statements are a conditional structure allowing you to check for multiple conditions by placing one if statement inside another. This is helpful when you need to perform a series of checks that are dependent on each other. This code checks for two conditions: temperature and whether it is raining. The outer if checks if the temperature is greater than 30 degrees. If it is, it goes into another set of if-else conditions to check if it is raining. If it is raining, it suggests staying inside. Otherwise, it suggests wearing sunscreen. In the case where the temperature is not above 30, it checks for rain again in a nested if, suggesting to bring an umbrella if it is raining, or to enjoy the day otherwise. This form of nesting provides a way to create more complex decision-making pathways. For loops, a for loop in Python is used to iterate over a sequence, such as a list, tuple, dictionary, set, or string. This iterative loop allows you to execute a block of code multiple times, which is particularly useful when you want to perform an action on each item in a sequence. In the provided code, range 5 generates a sequence of numbers from 0 to 4. The for loop iterates over this sequence, and with each iteration, the variable I takes on the next value in the sequence. The print I statement is then executed, printing each number from 0 to 4. While loops. A while loop in Python is used to repeatedly execute a block of statements as long as a given condition is true. It's useful when the number of iterations is not known ahead of time. The loop checks the condition before executing the block each time. In the provided code, the while loop runs as long as the variable count is less than 5. Inside the loop, it prints the current count and then increments count by 1. Once count reaches 5, the condition becomes false. The loop stops, and it prints done. Nested loops. In programming, a loop within another loop is called a nested loop. The inner loop will be executed one time for each iteration of the outer loop. This concept is often used to process items in multidimensional data structures. In the provided code, we have an outer loop, I loop, and an inner loop, J loop. For each value of I from 1 to 3, the inner loop runs completely, iterating J from 1 to 2. There are 3 iterations of the I loop, and for each, 2 iterations of the J loop, resulting in a total of 6 print statements. Break and continue statements. The break statement in Python is used to exit a loop prematurely when a certain condition is met. It is commonly used within for or while loops to break out of the loop once a specified condition becomes true. In the provided code snippet, a for loop iterates over a range of numbers from 0 to 4. When the number reaches 3, the break statement is executed, causing the loop to terminate immediately. Consequently, the numbers 0, 1, and 2 are printed, but the loop stops before printing 3 or continuing to 4. Pass statement. In Python, the pass statement is a null operation. Nothing happens when it executes. The pass is useful in places where your code will eventually go, but has not been written yet, e.g. in stubs for future functionality. It can be used within functions, loops, and conditionals where a statement is syntactically required, but you do not want to execute any code. In the provided code, we have a for loop that iterates over the range of numbers from 0 to 4, inclusive. Inside the for loop, we have used the pass statement to indicate that no action is to be taken for each iteration. This is a placeholder indicating where code will be added in the future. It tells Python to pass over this block without performing any operation. Loop else clause. In Python, loops, like for and while, can have an else clause that is executed after the loop finishes its iteration normally, without encountering a break statement. This feature is quite unique to Python and can be used to run a block of code once when the loop condition no longer holds true, or if the loop ran successfully without any interruption. Defining functions. In Python, a function is a reusable block of code that performs a specific task. Functions are defined using the def keyword, followed by the function name and a set of parentheses, which can enclose parameters. Functions can return values using the return keyword. The given code defines a function named greet that takes one parameter, name. The function returns a string that includes the value of the name parameter, formatted within a greeting. When you call greet with an argument, it will return hello argument. Calling functions. In Python, a function is a block of code that performs a specific task. Calling a function involves using its name followed by parentheses, which may include arguments. The code defines a function named greet with one parameter name. It returns a greeting string. The function is then called with the argument Alice, and the result is stored in the variable greeting. Finally, the greeting is printed out. Function arguments and parameters. In Python, functions are defined by using the def keyword, followed by the function name and parameters inside parentheses. Parameters act as placeholders for the arguments that will be passed into the function when it is called. There are several types of arguments: positional arguments, keyword arguments, default arguments, variable length arguments, and keyword variable length arguments. In this code, greet is a function with two parameters, name and message. The message parameter has a default value of hello. When greet is called with one argument, Alice, it uses the default message hello. The second call provides two arguments, Bob and goodbye, with goodbye overriding the default value for message. Thus, Alice is greeted with hello, while Bob is bid goodbye. Default arguments. In Python, default arguments allow you to specify default values for parameters when defining a function. These defaults are used if no explicit value is provided during the function call. A great use of default arguments is to provide common values that most calls to the function will use, simplifying the API and reducing the amount of code that needs to be written. In the provided code, we define a function greet with two parameters, name and message. The message parameter has a default value of hello. When greet is called with only one argument, message assumes the default value, resulting in hello Alice. However, when the second argument is provided, as in greet Bob good morning, it overrides the default and prints good morning Bob. This demonstrates how default arguments can be overridden by explicitly passing arguments. Keyword arguments. In Python, keyword arguments allow you to pass arguments to a function by explicitly specifying the name of the parameter and its corresponding value. This can enhance readability and allows for calling functions with arguments in any order as opposed to positional arguments. In the provided code snippet, the greet function is defined with two parameters, first name and last name. When calling greet, we use keyword arguments by specifying the names of the parameters and their corresponding values. This means that first name is set to John and last name is set to Doe, regardless of the order in which they are passed to the function. The function will output hello, John Doe when executed. Arbitrary argument lists. In Python, arbitrary argument lists allow you to create functions that can accept any number of arguments provided by the caller. This feature is particularly useful when you don't know beforehand how many arguments will be passed to your function. To define such a function, you use the args *args syntax, which collects any additional positional arguments into a tuple. Here's how you can use this in a function. In the code provided, the my function is defined to accept an arbitrary number of arguments. The *args is a parameter that captures all extra positional arguments passed to the function as a tuple. Inside my function, we iterate over this tuple with a for loop, printing out each argument. When you call this function with any number of arguments, e.g., my function 10, 20, hello, all arguments are collected into args and processed in the loop. Unpacking arguments. In Python, unpacking arguments involves breaking down the elements of a sequence or a dictionary so that they can be passed as individual arguments to a function. Using the asterisk for sequences like lists or tuples and double asterisk for dictionaries, we can effectively unpack these collections into separate arguments. In the provided code, we define a function print coordinates that takes two arguments, x and y. We then define a list chords list with 2 elements and a dictionary chords dict with 2 key value pairs. When calling print coordinates, we unpack chords list using a single asterisk, which passes its 2 elements as individual arguments. Similarly, we unpack chords dict using a double asterisk, which passes its values associated with keys x and y as named arguments to the function. This is a convenient way to pass multiple arguments to a function when they are already grouped in a sequence or a dictionary. Lambda expressions. In Python, a lambda expression is a small anonymous function that is defined using the lambda keyword. It can take any number of arguments, but can only have one expression. Lambda functions are often used for constructing small, one-time and inline function objects. The code defines a lambda expression that doubles the value passed to it. The lambda function is assigned to the variable double. When double 5 is called, the lambda expression is executed with x being 5, returning 10, which is then printed. Scope of variables. In Python, the scope of a variable is the region of the program where a variable is accessible. There are 2 main types of scope, global and local. A global variable is defined at the top level of the script and is accessible everywhere. A local variable is defined inside a function and is accessible only within that function. In the provided code, global var is a global variable which is accessible throughout the whole script, including inside functions like myFunction. Local var, however, is a local variable that is only accessible within the myFunction. Trying to print local var outside its scope, as is attempted in the commented out line, would result in an error because local var is not defined in the global scope. Function return values. In Python, a function can send back a value or result to the caller using the return statement. These returned values can be of any data type. A function without a return statement or with a return statement without a value implicitly returns none. In this code, we define a function called calculateSum with parameters a and b. Inside the function, we calculate the total of a and b and store it in a variable named total. The return total statement then sends this value back to the caller. When we call calculateSum57, the function returns 12, and this value is stored in the variable result. The print result then outputs 12. Docstrings and annotations. In Python, a docstring is a string literal that occurs as the first statement in a module, function, class, or method definition. It is used to explain what the code does or how it works. Docstrings are accessible through the doc attribute on objects and can be used by documentation generation tools. The code defines a function greet that takes a single argument, name. The first line inside the function is a docstring, which describes the purpose of the function. When we call greet.doc, it prints out the docstring. Recursion. Recursion in Python is a method where the solution to a problem depends on solutions to smaller instances of the same problem. A recursive function calls itself with modified parameters during its execution. In the provided code, we define a function factorial that computes the factorial of a number using recursion. If the input n is 0, the factorial is 1 by definition. Otherwise, the function returns n multiplied by the factorial of n-1. The recursion continues until it reaches the base case of n being 0. For example, factorial 5 calls factorial 4, which calls factorial 3, and so on, until factorial 0 returns 1, which then unwinds the recursive calls. Lists. In Python, a list is a mutable, ordered collection of items. Lists can contain items of different types and are defined by square brackets, with items separated by commas. Let's explore list creation, access, modification, and some common list methods. The code snippet shows basic operations on a Python list named myList. Initially, the list contains 3 integer elements. The append method adds the integer 4 at the end of the list. We then access the third element with index 2, since indexing starts at 0, and store it in the variable element. Next, we change the second element to the string Python, demonstrating list mutability. Finally, the len function is used to get the number of items in the list, which is stored in length. Tuples. In Python, tuples are immutable sequences used to store a collection of items. They are similar to lists, but cannot be changed once created. Tuples are defined by enclosing the elements in parentheses, and they can contain a mix of types. The provided code defines a tuple named mytuple with 3 elements, an integer 1, a string hello, and a float 3.14. It then prints each element of the tuple using indexing, with mytuple 0, accessing the first element, mytuple 1 the second, and mytuple 2 the third. This demonstrates how to access tuple elements by their index. Sets. A set in Python is an unordered collection of unique items. Sets are defined with curly braces and can be used to perform mathematical set operations like union, intersection, difference, and symmetric difference. Here is how you create a set and use basic set operations. The example shows basic set operations. It creates a set of fruits, then adds orange to the set and removes banana. Using in checks if apple is a member of the set. Union combines 2 sets without duplicates, while intersection gives the common items between 2 sets. Dictionaries. In Python, a dictionary is a collection of key-value pairs with unique keys and associated values. Dictionaries are mutable, and order of elements was made to be consistent starting from Python 3.7. They are defined with curly braces, and pairs are separated by commas. The code defines a dictionary named sample_dict, with fruit names as keys and numbers as values. It prints the value associated with the key banana, 2, then updates the value for banana to 12, and adds a new key-value pair, date, with the value 7. Upon printing the dictionary after these operations, we see the updated banana value and the newly added date entry. List comprehension. List comprehension offers a concise syntax to create lists in Python. It can be thought of as a single line of code that can replace multi-line loops for creating lists. It typically involves an expression followed by a for clause, and optionally can have if clauses to enforce conditions. This code generates a list of the squares of even numbers between 0 and 9. The expression x*2 is applied to each element from the range 10, which returns numbers from 0 to 9. The if clause filters out only the elements for which x%2 equals to 0, i.e., even numbers, to apply the expression. Set comprehension. In Python, set comprehension is a concise and readable way to create sets from iterable objects. Similar to list comprehensions, set comprehensions apply an expression to each element in an iterable, producing a set by filtering out duplicates and potentially applying conditions to each element. The provided code uses set comprehension to generate a set of squares for even numbers between 0 and 9. The for x in range 10 iterates through each number from 0 to 9. The if x%2 equals 0 applies a condition that includes only even numbers. The expression x*2 calculates the square of each even number, creating a set containing the results without any duplicates. Dictionary comprehension. Dictionary comprehension is a concise way to create dictionaries in Python. It is similar in spirit to list comprehensions, but for dictionaries. With dictionary comprehension, you can transform and filter data into key-value pairs with a single, readable line of code. In the provided code, we create a dictionary using a comprehension. For each key from 0 to 5, due to range 6, we compute the value as the square of the key, key to key. The resulting dictionary maps each into its square, producing 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Iterating over data structures. In Python, a list is an ordered collection of items that can be iterated over using a for loop. This allows us to execute a block of code once for each item in the list. The code defines a list named numbers with 5 elements. It then uses a for loop to iterate over each element in the list. The loop temporarily assigns each element to the variable number and prints it to the console. The output will be the numbers 1 through 5, each on a new line. Nested data structures. Nested data structures are data structures that contain other data structures. This is a common way to manage complex data where you store data structures like lists, dictionaries, or sets within similar or different types of data structures to create a hierarchy or a multi-level indexing system. The code presents a nested dictionary in Python. The outer dictionary contains one key-value pair. The key is first level, and the value itself is another dictionary with its own key-value pair. Second level, key value. This structure allows you to access nested values using sequential key indexing, like nested dict first level, second level key, which would return value. Slicing. In Python, slicing is used to access a range of items in a sequence type, like strings, lists, tuples, etc. It is performed by using a colon operator with square brackets, where you can specify the start, stop, and step of the slice. The code defines a list of characters. It then prints the slice of this list from index 2 to 4. The slicing syntax 2.5 indicates the start index is 2 and stop index is 5, not including the item at index 5. The output will thus be a sublist containing C, D, E. Mutability of data structures. In Python, data structures can be categorized as mutable or immutable. Mutability refers to the ability to change an object after its creation. Mutable data structures, such as lists and dictionaries, can be altered, whereas immutable data structures like tuples and strings cannot be modified after creation. Understanding mutability is crucial while writing Python programs, as it affects how you manage data, and it also plays a significant role in optimization and potential error avoidance. In this code, mutable list is a list, which is a mutable data structure, so its elements can be changed. We changed the first element from 1 to 100 without any error. Immutable tuple, however, is a tuple, which is an immutable data structure, so when we try to change the first element, it raises a type error. This illustrates the fundamental behavior of mutable and immutable data structures in Python. Data structure methods. The append method in Python is used to add a single element to the end of a list. In this code, we start with a list mylist containing the elements 1, 2, 3. We then use mylist.append4 to add the element 4 to the end of the list. After appending, mylist becomes 1, 2, 3, 4. Importing modules. In Python, a module is a file containing Python definitions and statements. Importing a module means to bring into your script the functions, classes, variables defined in another module. In this code snippet, we import the math module, which provides access to mathematical functions. We then call the squat function from the math module to calculate the square root of 16 and print the result. Creating modules. In Python, a module is a file containing Python definitions and statements. A module can define functions, classes, and variables. When you create a module, you can reuse the functionality encapsulated in it in other Python scripts by importing it. The first file, modulename.py, defines a function greet and a variable favorite number. This file is our module. The second file, another file.py, demonstrates how to use the module. It imports module name and then calls the greet function from that module, passing Alice as an argument. It also accesses the favorite number variable defined in the module. When using an imported module, you need to prefix its functions and variables with the module's name, followed by a dot, modulename.function. Exploring standard library. Python's standard library is a collection of modules available without the need for additional installation. These modules provide a wide range of functionalities, from mathematical operations to handling dates and times. In the provided code, we import the math module from the standard library, which includes a collection of mathematical functions and constants. We then use the squat function to calculate the square root of 16 and print it out. We also print the value of the mathematical constant pi, which is an attribute of the math module. Package installation and management pip. Pip is the package installer for Python. It allows you to install and manage additional libraries that are not part of the Python standard library. Understanding how to use pip is key to extending the functionality of your Python environment. The code uses the pip tool to install a Python package. You would replace package name with the actual name of the package you wish to install. This command is executed in the command line interface, such as the terminal in macOS Linux or command prompt PowerShell in Windows. Virtual environments. In Python, a virtual environment is an isolated environment that allows you to manage separate package installations for different projects. Using virtual environments prevents package versions from interfering with each other and allows for more reliable dependency management. This code snippet demonstrates how to create and use a virtual environment in Python. First, the python-env mynv command creates a new virtual environment named mynv. Next, source myenv/bin activate activates the virtual environment for the current shell session, changing the command prompt to indicate that myenv is active. Lastly, pip install requests installs the requests package inside the virtual environment, keeping the installation separate from the system's global Python installation. Creating packages. In Python, a package is a directory of Python modules which contains an additional init.py file, signaling Python that this directory should be treated as a package. Packages help organize code into namespaces and shareable units. The structure shows a package named myPackage with two modules, Module 1 and Module 2. The init.py file can include package initialization code. To use the package, one can import it using import myPackage, which will execute the initializer function. Individual modules can be imported using from myPackage import module 1, and their functions can be invoked with module1.function1. Name and main. In Python, name is a special built-in variable which evaluates to the name of the current module. However, when a module is run directly, name is set to main. By checking if name equals main, a script can determine if it's being run directly or being imported elsewhere. The code checks if name is main to see if the script is the entry point of the program. If it is, it prints a message indicating that the script is run directly. If not, meaning the script is imported into another module, it prints a different message. This is useful to prevent certain parts of code from running when the module is imported. Reading files. Reading files is a common task in Python. Python provides built-in functions to read the contents of a file stored on disk. The open function is used to open a file and access it in the desired mode. R for read, W for write, etc. The code snippet demonstrates how to read from a file named example.txt. The with statement is used to open the file and ensure it's properly closed after its block is executed. Open is called with R to specify read mode. File.read reads the entire file's content into the variable content. Then, print content prints the content to the console. Writing files. In Python, writing files involves using built-in functions to create or overwrite files. It includes opening a file, writing or appending content, and then closing it properly. The with statement ensures the file is properly closed after its block of code runs. Open function is used with the W mode to write to example.txt. If the file exists, it is overwritten. If not, it's created. Write method writes a string to the file. Appending to files. Appending to a file means to add new content to the end of the file without altering the existing content. This is done in Python using the A mode with the open function. The with statement ensures the file is properly closed after its sweep finishes. Open is used with A mode for appending. File.write adds text to the file. N creates a new line. Working with files mode. In Python, when working with files, you'll need to specify the mode while opening a file. The mode indicates how the file is going to be opened, R for reading, W for writing, A for appending, R+ for both reading and writing, etc. Here, open is used to open a file named example.txt in read mode, R. The with statement ensures proper acquisition and release of resources. The file contents are read using file.read and stored in the variable content. File handling with statement. In Python, the with statement is used for resource management and makes the code that deals with system resources such as file streams more robust and readable. When dealing with file operations, it ensures that the file is properly closed after its sweep finishes, even if an exception is raised. The code block opens example.txt in read mode as file. The with statement handles opening and closing the file. Content is assigned the text in example.txt. The file is read using file.read and the contents are printed. After the block, with automatically closes the file. Handling file paths. In Python, handling file paths is important when reading from or writing to files. The OS and pathlib modules provide functions to manipulate file paths and names in a platform-independent way. The code demonstrates two methods for handling file paths in Python. The OS module's os.path.join function is used to combine directory names into a single path string. The pathlib module, introduced in Python 3.4, uses the path class to create an object that represents the file path, allowing you to use the division operator / to join paths. This makes handling paths more intuitive and readable. Both methods are cross-platform and will handle directory separators, or, appropriately, for the operating system. File operations rename, delete. In this example, we're going to look at how you can rename and delete files in Python using the os module. The code uses the os module, which provides a way of using operating system-dependent functionality. os.rename is used for renaming a file. It requires two arguments, the current file name and the new file name. os.remove is used to delete a file. It takes one argument, which is the file name of the file you want to delete. Ensure the file you want to manipulate exists, and that you have the necessary file permissions. Byte streams. In Python, byte streams are used to read and write binary data. The built-in I/O module provides tools for working with these data streams. Below we have an example that writes bytes to a file and then reads them back. The code uses io.bytes.io to create a buffer for byte data. Buffer.write writes binary data, noted by the B prefix. Buffer.seek0 resets the reading position to the start. Buffer.read reads the contents. Finally, we close the buffer with buffer.close to free up resources. Text versus binary mode. In Python, files can be opened in text mode or binary mode. Text mode interprets the file content as characters and automatically decodes to the default or specified encoding, handling universal newlines. Binary mode treats the file bytes as is, without conversion, which is important for non-text file types. The code demonstrates opening files in text, RT, and binary, RB modes. Example.txt is read as a string with decoded text, while example.bin is read as bytes without decoding. The types printed at the end, str and bytes, show the difference between the content read in each mode. Try and except blocks. In Python, try and except blocks are used to handle exceptions. An exception is an error that occurs during the execution of a program. The try block lets you test a block of code for errors, while the except block lets you handle the error. In the provided code, we attempt to divide 10 by 0, which will raise a 0 division error. The try block contains this potentially problematic division, and if an exception occurs, the program immediately jumps to the except block. Here, instead of the program crashing, it prints a user-friendly message: you cannot divide by 0. Handling multiple exceptions. In Python, you might encounter situations where a block of code could throw more than one type of exception. You can handle multiple exceptions in a single try except block by specifying each exception type in a tuple after the except keyword. This allows you to respond to each exception appropriately, or you can catch all types of exceptions using a generic except exception as E block, though the latter is less precise. The code demonstrates how to handle multiple different exceptions that may occur when taking user input and performing arithmetic. The value error and type error are grouped together to handle cases of invalid input or type issues. The division by 0 case is handled by catching 0 division error. Lastly, a generic exception is caught to handle any unexpected error that is not explicitly handled in the prior exception blocks. Else clause in exception handling. In Python, the else clause in exception handling is used to specify a block of code that is to be executed if no exceptions are raised by the try block. It is placed after all the except blocks and before any finally block. The provided code attempts to open and read a file named file.txt. If the file does not exist, a file not found error will be raised, and the corresponding except block will be executed, printing error, file not found. If no exceptions occur in the try block, the else block is executed, printing file opened successfully, indicating the file was opened and read without issues. The finally block will execute regardless of whether an exception was raised or not. In this case, it prints executing finally block, which signifies the completion of the try except else finally construct. Finally clause. In Python, the finally clause is used to specify a block of code that will be executed no matter what, after try and except blocks have been executed, regardless of whether an exception was raised or not. It's generally used for cleanup activities such as closing files or releasing resources. In this code snippet, the try block contains code that will raise a zero division error. The except block will catch this exception and print a message. Regardless of whether the exception was caught, or even if no exception was raised at all, the finally block will run, printing finally block executed. This ensures that the finally block is used to execute important cleanup code that must run no matter what happens in the try and except blocks. Creating custom exceptions. In Python, custom exceptions provide a way to create and use your own types of exceptions that are specific to your application's context. They are useful when you want to handle certain types of errors differently or provide more detailed error information. Custom exceptions are defined by creating a new class that inherits from the built-in exception class or one of its subclasses. In the provided code, we define a custom exception called myCustomError, which inherits from Python's built-in exception class. The constructor, init, is overridden to accept an optional message parameter with a default value of a custom error occurred. When raising myCustomError, you can provide a specific error message. In the example, we raise myCustomError with something went wrong as the argument. The subsequent except block catches only exceptions of type myCustomError, ensuring that this error can be handled separately from other exception types. Raising an exception. In Python, exceptions are events that can occur during program execution that disrupt the normal flow of a program. Raising an exception means intentionally causing an exception to occur, usually because a certain condition has not been met, or an error has been detected. By raising an exception, you signal to the program, or the code that may handle this exception, that an error condition has arisen, which can't be managed within the current scope. In the provided code snippet, a check is performed to see if the variable user age holds a value that is less than 0, which is not a valid age. If this condition is true, the code raises a value error with an appropriate error message, age cannot be negative. This halts the execution of the program at that point, and the exception must be handled by the calling code, or it will result in the program terminating with an error message. Exception chaining. In Python, when an exception is raised while another exception is already being handled, the new exception can be chained to the original one. This process is called exception chaining. It's useful for providing a context when handling exceptions, where the cause of an exception needs to be tracked. Python 3 introduced the raise from syntax to explicitly chain exceptions. In the code, we first attempt to open a non-existent file, which raises an I/O error. While handling this I/O error, we reference an undefined variable, initiating a name error. Instead of losing the context of the original I/O error when the name error is raised, we explicitly chain the exceptions by using raise from for syntax. This raises a new runtime error explicitly indicating that it was caused by the original I/O error. This way, we preserve the exception chain, which can be invaluable for debugging purposes, as it maintains the causality link between the original error and subsequent errors. Assertions. In Python, assertions are a handy way to place sanity checks within your code at development time. They are used with the assert statement, which will cause your program to halt as soon as a false condition is encountered, letting you find logical errors more easily. In the given code snippet, we declare a variable x with a value of 10. Then we use the assert statement to check if x is less than 20. The second part of the assert statement, the value of x should be less than 20, is the error message that is printed if the assertion fails. Because 10 is indeed less than 20, the assertion will pass and nothing will happen. If x were greater than or equal to 20, the assertion would fail and the program would raise an assertion error with the provided message. Classes and objects. In Python, a class is a blueprint for creating objects. An object is an instance of a class with properties and behaviors defined by the class. Here's a simple example. In the provided code, dog is a class with a init method to initialize its attributes. Bark is a method for behavior. Dog1 is an object of the dog class, created with a name Buddy and age 4. When bark is called, it prints out the message indicating that the dog is barking. Attributes and methods. In Python, attributes are variables that belong to an object, and methods are functions that belong to an object. Every object in Python may have attributes to store its state and methods to modify its state or perform computations. The code defines a class car with an isOrinit method that initializes attributes color and brand. Start is a method of the class that uses the color and brand attributes to print a message. An object car1 is created from the car class, which calls the start method and prints the color attribute. Constructor init method. In Python, the constructor method is used to initialize a newly created object. It is called immediately after the object has been created, allowing the object to be customized by passing parameters. Let's explore how this works with a simple class definition for a car. In the provided code, the class car is defined with an init method that takes 3 parameters: make, model, and year, in addition to self. The self parameter is a reference to the current instance of the class, and it is used to access variables and methods belonging to the class. When we create a new car object with car Toyota Corolla 2020, the getInit method is automatically called, setting the attributes of the car to the provided values, Toyota, Corolla, and 2020 respectively. Instance class and static methods. In Python, there are 3 types of methods that can be defined within a class: instance methods, class methods, and static methods. Instance methods take self as the first parameter and can access and modify object instance state. Class methods take CLS as the first parameter and can access and modify class state. Static methods do not take a self or CLS parameter and are not meant to modify class or instance state. The code defines a class myClass with one class variable counter. It has an instance method that can access object self attributes, a class method that can access the class CS attributes, and a static method that does not access any object or class attributes. It creates an instance of myClass and calls each type of method to show how they are used. Access modifiers: public, protected, private. In Python, access modifiers are not enforced like in some other languages such as Java or C++. Instead, there's a convention that is followed by the community. A name prefixed with an underscore should be treated as a non-public part of the API, whether it is a function, a method, or a data member, while 2 leading underscores indicates a name that will be mangled to create a private variable. In the given code example, public variable is a public attribute, meaning it can be accessed from outside the class. Protected variable is a protected attribute, indicated by a single underscore, suggesting it should be accessed within the class and its subclasses only. Private variable is a private attribute, denoted by 2 leading underscores, and its name is mangled to prevent direct access from the outside. Public and protected methods are defined similarly. The single and double underscores before a method name imply the same level of protection as they do with attributes. Inheritance. Inheritance is a fundamental concept in object-oriented programming that allows a class to inherit methods and properties from another class. It enables code reusability and the creation of a hierarchical structure of classes. In the provided code, animal is a base class, and dog and cat are derived classes that inherit from animal. The animal class has an recursion method that initializes an animal instance with a name attribute, and a speak method which is intentionally left empty with pass. Both dog and cat classes override the speak method to provide their unique implementations. When speak is called on an instance of dog, it returns woof, and when called on an instance of cat, it returns meow. This demonstrates how inheritance allows derived classes to customize or extend the behavior of their base classes. Method overriding. In object-oriented programming, method overriding occurs when a subclass or child class has a method with the same name as a method in the parent class. In the given code, we define a parent class with a method named display. The child class, which inherits from parent, overrides the display method. By doing so, any instance of child will use its version of display and not the one from parent. When we create an instance of child and call the display method, the overridden version in the child class is executed, and we see display method overridden in child printed out. Multiple inheritance. Multiple inheritance is a feature in Python that allows a class to inherit attributes and methods from more than one parent class. This enables the creation of a class with combined functionalities of its parents. The code defines two parent classes, parent A and parent B, with methods method A and method B, respectively. Next, it defines a child class inheriting from both parent A and parent B. The child class has its own method, method C. An instance of child is created and can access methods from both its parent classes, as demonstrated by calling method A, method B, and its own method C. This showcases how multiple inheritance allows the child class to use the combined interface of both parent A and parent B. Polymorphism. Polymorphism is a core concept in object-oriented programming, OOP, that refers to the ability of different objects to be accessed through the same interface, with each object responding to the interface in a different way. This is achieved by methods that can operate on objects of different classes. In the provided code, both bird and dog classes have a method named sing. The sound function takes an animal object as a parameter and calls its sing method. This demonstrates polymorphism because the sing method is being called on instances of different classes, bird and dog, and each class has a unique implementation of the sing method. A bird tweets and a dog barks. This allows for writing code that can operate on different types of objects, as long as they provide a common interface, increasing flexibility and reusability. Encapsulation. Encapsulation is a fundamental concept in object-oriented programming that involves bundling data with methods that can manipulate that data. It restricts direct access to some of an object's components, which is a means of preventing accidental interference and misuse of the methods and data. The code defines a class car with private attributes, core_model, and core_year. It provides public methods getModel, setModel, getYear, and setYear to interact with these attributes. Such design pattern allows encapsulating the implementation details and provides a public interface for the functionalities. This prevents direct modification of the attributes, as seen with myCar.model=Ford, which doesn't actually change the car's model because core_model is private. The output will still be Honda due to the encapsulation provided by the getter method. Composition versus aggregation. In object-oriented programming, both composition and aggregation are used to represent relationships between objects. Composition implies a strong ownership, while aggregation implies a weaker relationship. With composition, the lifetime of the owned object is tightly coupled to the lifetime of the owner. In contrast with aggregation, the owned object can exist independently of the owner. In the provided code, the car class composes an engine, meaning it has an engine as an integral part. The start method in car calls the start method of the engine class to demonstrate the tight coupling. The garage class, however, aggregates a car. It takes a car instance in its constructor, but doesn't create it. This means a car object can exist without a garage, but the engine does not operate independently from the car, illustrating the autonomous existence in aggregation and the dependency in composition. Magic methods. In Python, magic methods are special methods with double underscores at the beginning and end of their names. They are also known as dunder methods. These methods allow us to override or define behavior for operations like addition, subtraction, or comparisons, and many others, such as object representation or the creation and destruction of objects. The given code defines a circle class with a custom constructor, scornInit, that initializes an instance with a radius. It includes a repr method that provides a developer-friendly string representation of the object. It also includes an add method that allows two circle instances to be added using the plus operator by creating and returning a new circle with the combined radius. In the provided example, circle 1 and circle 2 are added, and a new circle instance with the combined radius is returned. Class decorators. In Python, decorators are a way to modify or enhance the functionality of functions or classes. Class decorators are specifically used with classes, allowing us to alter or augment a class definition in a clean and readable way. By applying a decorator to a class, you can run additional code before or after the class is created without altering the class's original code. The provided code defines a class decorator, myClassDecorator, which wraps the original class myClass. Inside the decorator, a modification is made to the class by setting an attribute modified to true. When myClass is instantiated, the decorator is executed, modifying the class before an instance is created. This is a simple example of how decorators can add functionality to classes. The @symbol applies the myClassDecorator to myClass, and when we create an instance of myClass, it has the modified attribute set to true. Class and static variables. In Python, class variables are shared across all instances of a class, while static variables don't necessarily belong to any instance or class. Class variables are defined within the class construction, while static methods usually use the @static method decorator and don't take a self-parameter as they do not require access to the instance. In the code provided, class variable is a class variable that will be the same for all instances of myClass. The instance variable is unique to each instance. Static method is a static method which doesn't interact with instance or class variables, meaning it does not require a reference to a class or an instance, and can be called on the class itself. Iterators and generators. An iterator in Python is an object that contains a countable number of values and can be iterated upon, meaning you can traverse through all the values. It implements the iterator protocol, which consists of the methods iter and next. In this code, nums is a list, which is an iterable. The iter function is used to create an iterator object. The next function is then used to access the next element in the iterator. After the last element is reached, further calls to next will raise a stop iteration exception. Decorators. Decorators in Python are a powerful way to modify or enhance the behavior of functions or methods without changing their actual code. They are defined by the @symbol followed by the name of the decorator function. The decorator func takes in a function originalFunc as an argument and defines an inner function wrapperFunc that adds some behavior before and after originalFunc gets executed. WrapperFunc is then returned by the decorator. When displayInfo is called, it's wrapped by the behavior defined in wrapperFunc. Context managers. A context manager in Python is a concept that allows for the allocation and release of resources precisely when you want to. The most common way to implement a context manager is using the with statement, which can help to manage resources like file streams, locks, and database connections. It ensures that resources are properly acquired and released, reducing the chance of resource leaks. In the provided code, we are using the with statement to handle the opening and closing of a file. Open is a built-in context manager for file operations that takes care of opening the file, returning a file object, and eventually closing the file when the block of code within the with statement has completed. The example.txt will be opened in write mode W, then hello world is written into the file. After the code block is exited, the file is automatically closed by the context manager, even if an error occurs within the block. Property getter and setter. In Python, properties provide a way of customizing access to instance attributes. They are created with the @property decorator, which makes a method behave like an attributes getter. To set the value of the attribute, the @setter decorator is used alongside the property. In the provided code, a class circle is defined with a private attribute scoreRadius. The @property decorator above the radius method allows us to get the radius value. The @radius.setter decorator is used to define a method with validation logic, ensuring that a positive value is set for radius. If an attempt is made to set a negative radius, a value error is raised. This approach encapsulates the internal representation of the attribute and validates against incorrect assignments. Descriptors. Descriptors are objects that define how attribute access is interpreted by the Python interpreter. They provide a protocol for customizing attribute access. A descriptor is an object with any of the following methods: get, set, and delete. If any of these methods are defined for an object, it can be considered a descriptor. The most common descriptors are properties and methods. The code defines a descriptor class with coinit, get, set, and delete methods. When used as a class attribute in the my class, any access to attribute will call the corresponding descriptor method. Core get is called when the attribute value is retrieved, set when a value is assigned to the attribute, and delete when the attribute is deleted. The myClass instance demonstrates how the descriptor controls access to attribute. Getting the attribute prints a message and returns the value. Setting, it prints a message and changes the value, and deleting it prints a message and removes the attribute. Metaclasses. Metaclasses in Python are a deep concept that define the behavior of classes themselves. They are often referred to as classes of classes, that is, a metaclass creates classes, just like a class creates instances. Using metaclasses, you can control the creation of classes, modify class attributes, or define class methods dynamically. In this code, meta is a metaclass that inherits from type, which is the default metaclass in Python. When myClass is created, it specifies that meta is its metaclass. When myClass is instantiated, the new method of meta is called before myClass is created. It adds an attribute atter with the value of 100 to myClass. Therefore, when we print myClass.atter, it outputs 100. This illustrates how metaclasses can be used to customize class creation. Concurrency and parallelism. Concurrency and parallelism are related concepts, but they refer to different ways in which multiple tasks can be managed within a program. Concurrency refers to the ability of the program to deal with many tasks at once by context switching between them, often giving the illusion of simultaneous execution. Parallelism, on the other hand, refers to actually executing multiple tasks at the same time, which is possible on multi-core processors. The code snippet demonstrates concurrency in Python using threading. Two functions, print numbers and print letters, are executed concurrently by creating two threads T1 and T2. When we start these threads with T1.start and T2.start, the Python interpreter schedules and switches between them, allowing interleaved execution. Finally, T1.join and T2.join ensure that the main thread waits for both threads to complete before it finishes. This is not true parallelism, as it's subject to the global interpreter lock (SIRL), which allows only one thread to execute at a time in the CPU. Coroutines and async await. In Python, coroutines are a type of function that allows you to pause and resume execution while waiting for some activities without blocking the event loop. Introduced in Python 3.5, async and await are the keywords used to define and work with coroutines in an easier and more readable way. Async defines a coroutine, and await is used to pause the coroutine's execution until the awaited task is completed. In this snippet, the main function is defined as a coroutine using the async keyword. Within it, print hello executes immediately. The await keyword then pauses the coroutine for approximately 1 second during the asyncio.sleep1 call, allowing other tasks to run if there were any. After the sleep, the coroutine resumes by printing world. The asyncio.run main is the entry point for executing the main coroutine. Asynchronous I/O. Asynchronous I/O, often abbreviated as async I/O, is a form of input-output processing that allows other processing to continue before the transmission has finished. In Python, this is achieved using the asyncio library, which provides the infrastructure for writing single-threaded concurrent code using coroutines, multiplexing I/O access over sockets and other resources, running network clients and servers, and other related primitives. In the code provided, we define fetch data as an asynchronous function that simulates a data fetching operation using asyncio.sleep2, which is an async version of time.sleep2, but non-blocking. Then we define main function to orchestrate the workflow. It starts by printing before fetching, then awaits the completion of fetched data, prints the fetched result, and lastly prints after fetching. The asyncio.run main function call at the bottom is used to execute the async function main function. Note that await can only be used inside async functions. Memory management. Python uses automatic memory management, which means it has a built-in garbage collector that recycles unused memory. Understanding how Python handles memory allocation and deallocation is essential for writing efficient programs. Let's explore how Python manages memory with reference counting and garbage collection. The sys.getRefCount function returns the reference count for a given object, which indicates how many times an object is referenced. In this code, we create an integer object with the value 10 and assign it to variable a. We then create a reference to the same object with variable b. The reference count for the integer object would be 3, which includes the reference from a, b, and the argument passed to getRefCount. Garbage collection. Garbage collection, GC in Python, is a mechanism that automatically handles memory management. It involves identifying and disposing of objects that are no longer in use to free up space. Python uses reference counting alongside a cyclic garbage collector to accomplish this. The code snippet defines a function createCycle, which creates a list and appends a reference to itself, forming a circular reference. In the main function, createCycle is called. Then the garbage collector is invoked using gc.collect, which returns the number of objects it collected. The print statement displays this count. Without GC, the circular reference created in createCycle would prevent the list's memory from being freed, even if it's no longer needed. Debugging with PDB. Python's PDB module is a powerful interactive debugging environment. It allows you to execute code line by line, inspect variables, set breakpoints, and evaluate expressions on the fly. In this code, we import the PDB module and define a function calculateSum that calculates the sum of a list of numbers. We then insert a breakpoint using pdb.setTrace within the function. When executed, the program will stop at the breakpoint, allowing you to inspect variables, step through the code, and continue execution interactively. Using assert statements. Assert statements are a debugging aid that tests a condition as an internal self-check in your program. They are used to inform developers about unrecoverable errors in a program. An assert statement contains an expression which is supposed to be always true at that point in the program. If the expression evaluates to false, an assertion error is raised with the optional message provided. In this code, the function applyDiscount takes two parameters, product price and discount. It uses an assert statement to check that the discount rate provided is within the range of 0 to 1, effectively between 0% no discount and 100% free. If this condition is not met, the program raises an assertion error with the message, discount must be between 0 and 1. Then the discounted price is calculated, and a second assert statement validates that the new price does not exceed the original product price, ensuring the discount was applied correctly. If this assert fails, it raises an assertion error with the message, new price should not exceed original price. Writing test cases. Writing test cases is a crucial part of software development, ensuring that your code works as expected. Test cases are implemented as functions that assert the behavior of your code. A popular testing framework for Python is unit test. The provided code defines a test case class, TestSum, that inherits from unittest.testCase. It contains two test methods, TestSum and TestSumTuple. Each test method uses assertEqual to check that the sum of a list or tuple equals the expected result. If the test passes, it means the sum function is working correctly for that input. To run the tests, unittest.main is called when the script is executed as the main program. Introduction to Unit Test module. The unit test module in Python is used for automating testing of Python code. It provides a way to create test cases, which are scenarios that check the correctness of a specific part of the program. By using a series of assertions, tests can ensure that code behaves as expected. This tutorial will show you how to create a simple test using the unit test module. The code imports the unit test module and defines a test case class, testString methods, inheriting from unittest.testCase. Inside this class, two test methods, testUpper and testIceUpper, verify the .upper string methods functionality. TestUpper checks that calling .upper on foo results in foo. TestIceUpper ensures that foo, iceUpper, returns true and foo, iceUpper returns false. At the bottom, unittest.main is called to run the tests when the script is executed directly. Test suites. In Python, a test suite is a collection of test cases, test suites, or both. It is used to aggregate tests that should be executed together. Test suites are especially useful in large projects to organize tests in a structured manner. The unit test framework in Python provides the features needed to group together related test cases. The provided code is incomplete as it is intended for a conceptual explanation. To create a test suite using Python's unit test framework, one would define test case classes that inherit from unit test case, then use a test loader to add test cases or test suites to a main test suite. Finally, the test runner is used to run the tests grouped in the suite. This workflow helps in creating organized, maintainable, and scalable test structures for larger projects. Mocking objects. In testing, mocking objects are used to simulate real objects with predefined behaviors. This is particularly useful in unit tests where you want to isolate the code being tested. By replacing complex, unpredictable, or external dependencies with mocks, you can focus on the specific functionality without worrying about those dependencies. In the code, magic mock from the unittest.mock module is used to create a mock object. A real class, production class, with a method is mocked out. In a testing scenario, instead of using production class.method, we assign the mock to production instance.method to simulate its behavior. With production instance.method 123, the method is called with arguments 123. The last line, mock.assert called once with 123, is an assertion checking that the mock was called once with the exact arguments specified. Integration testing. Integration testing is the phase in software testing in which individual software modules are combined and tested as a group. It is conducted to evaluate the compliance of a system or component with specified functional requirements. In Python, we can perform integration tests using testing frameworks such as unit test or PyTest. Here's an example using unit test to test the integration between two components, a database connector and an application logic module. In the provided code snippet, we have an integration test case that uses the unit test framework to test the interaction between a database connector and an application. The test integration class inherits from unittest.testCase. Inside the class, we have a single test method, testIntegration, that creates instances of the database connector and application, passing the database connector instance to the application. Then we call app.processData, which should return true if the integration is successful. The assertTrue method checks if process data returns true, and if not, the test will fail with the message integration between components failed. Code coverage. Code coverage is a software testing metric that determines how much of the source code of a program is executed when a particular test suite runs. It helps in identifying untested parts of a code base. Code coverage tools can be used while running the test suite to collect coverage data. In Python, a popular tool for measuring code coverage is coverage.py. This code provides a basic test case using Python's unit test framework. The testMyFunction method tests my function from my module. The commands at the end are used to run the test with coverage analysis. Coverage run shem unit test discover executes the test suite while collecting coverage data, and coverage report generates a report of the code coverage. Introduction to DB API. The Python Database API, DB API, provides a standard interface for interacting with databases. It allows you to connect to various database systems, execute queries, retrieve results, and handle transactions. Below is an example using the SQLite database with the SQLite 3 module, which is included in Python's standard library. First, the SQLite 3 module is imported. Then a connection to an SQLite database file, example.db, is established. A cursor object is created, which is used to execute SQL commands. The create table SQL command is executed to create a new table if it doesn't already exist. An insert into statement adds a new row to the table. Changes are saved to the database with commit. Finally, the connection is closed using connection.close. This provides a basic introduction to interacting with a SQLite database using the DB API. Connecting to databases. In Python, connecting to databases is a common task for data retrieval, storage, and manipulation. This is usually done using third-party libraries that provide an interface to the specific type of database. One ubiquitous example is the SQLite 3 module, which is used to connect to SQLite databases and is included in Python's standard library. For other types of databases, such as MySQL or PostgreSQL, modules like MySQL Connector Python and scicop2 are utilized respectively. In this code, we import the SQLite3 module to work with an SQLite database. First, we establish a connection to the database using SQLite3.connect, specifying the database file. We then create a cursor object, which is used to execute SQL queries. After executing a query with cursor.execute, we retrieve the results using cursor.fetchAll. Finally, it's crucial to close the connection with connection.close to free up resources. Executing SQL commands. Python provides various libraries for interacting with databases. One of the most commonly used libraries for working with SQL databases is SQLite3 for SQLite databases. Below is a basic example of how to execute an SQL command. The code sample provides a minimal example of how to interact with an SQLite database in Python using the SQLite3 module. It begins by importing this SQLite3 library. Then, it establishes a connection to a database file example.db. It creates a cursor object, which is used to execute SQL commands. A table called people is created with columns for ID, name, and age. The commit method saves the changes, and close method is used to properly close the database connection. Transaction management. Transaction management refers to the process of managing changes made to a database in a coherent and reliable way. It's crucial in ensuring that the database remains in a consistent state even in the face of errors or failures. Python's DB API provides a standard for transaction management when interacting with relational databases. In the provided code, we use the SQLite3 module to manage database transactions. A transaction is initiated before making any changes with begin transaction. Then, we attempt to insert data into the students table. If the insert operations are successful, we commit the changes to the database, making them permanent. If an exception occurs during the operations, the transaction is rolled back, undoing all changes made during the transaction. In the end, we ensure that the database connection is closed whether an exception occurred or not. Working with cursors. In the context of databases, a cursor is a control structure that enables traversal over the records in a database. It works as an iterator that allows you to fetch and manipulate the data row by row. Python provides a standard way to work with cursors using the DB API. When using a cursor in Python to interact with SQL databases, you would typically follow these steps. Connect to the database, create a cursor object, execute a query, fetch the results, and then close the cursor and connection. In the given code, we first import the SQLite3 module, which allows us to work with SQLite database. We create a connection to an SQLite database example.db. Using that connection, we create a cursor object that lets us execute SQL queries. We create a table named users if it doesn't already exist, then insert a new row into the table. After executing the changes with commit, we select all rows from the users table and fetch the results with fetchAll. Finally, we iterate over the result set, print each row, and close the cursor and connection to clean up. Using ORMs, e.g. SQL Alchemy. Object Relational Mapping, ORM, is a technique that allows you to query and manipulate data from a database using an object-oriented paradigm. SQL Alchemy is a popular ORM in Python. It abstracts away the direct use of SQL, providing a high-level interface for accessing and manipulating database records without needing to write raw SQL queries. In the code provided, SQL Alchemy is used to define a user class mapping to a users table in a SQLite database. Declarative base creates a base class for declarative class definitions. The user class inherits from this base class and describes the table schema. Create engine establishes a connection with the database. Base.metadata.createAll creates the table if it doesn't exist. Session Maker returns a class to create session objects to bound to the database. We instantiate a session, add a new user object to the session, and commit it to the database to persist the new record. Model definitions. In the context of object-oriented programming, a model is typically a class that represents a table in a database. When you define a model in Python, you are creating a blueprint for how that object's data should be structured and its behavior. The code snippet defines a class named user that models a user with a username and email. The init method is called when an object is created from the class, which initializes the instance variables username and email with the values passed when constructing an instance of user. Querying database. Querying a database in Python often involves using a specific library, like SQLite for an SQLite database or psychobg2 for PostgreSQL. The process generally includes connecting to the database, creating a cursor object to execute queries, executing a SQL query, fetching results, and handling exceptions. In the code block, we import the SQLite 3 module to work within SQLite database. We then connect to the database with connect and create a cursor object. With this cursor, we execute a SQL query that selects all users older than 20. The fetchAll method then retrieves all matching rows. Finally, we close the connection to free resources. Understanding web frameworks. A web framework is a code library that makes web development faster and easier by providing common patterns for building reliable, scalable, and maintainable web applications. Python offers several web frameworks, such as Django, Flask, and Pyramid. The given code is a basic Flask application. Flask is a micro web framework for Python. The Flask class instance app is created, which starts the WSGI web application server. The @app.route/decorator defines the route for the root URL, i.e. /. When this URL is visited, the hello function is called, returning the string hello world. Finally, the conditional if nene equals main ensures that the server is only run if the script is executed directly, not if imported as a module. Introduction to Flask. Flask is a micro web framework written in Python. It is classified as a micro framework because it does not require particular tools or libraries. It has no database abstraction layer, form validation, or any other components where pre-existing third-party libraries provide common functions. However, Flask supports extensions that can add application features as if they were implemented in Flask itself. The provided code snippet is a basic Flask application. When run, it will start a web server on the local machine. The @app.route/decorator tells Flask that the hello world function should be called when the root URL / is accessed. When a request is made to the root of the app, the hello world function is invoked, and the string hello world is returned to the browser. The if name equals or main check ensures that the web server is started only if the script is executed directly rather than imported as a module. URL routing. URL routing is a system that directs HTTP requests to the correct code to handle them. In web frameworks like Flask for Python, routes are defined using decorators to map URLs to functions. The code snippet defines a basic Flask application with a single route. The @app.route/decorator tells Flask that the home function should be called when the root URL is accessed. When you run this application, visiting the root URL will display welcome to the home page. The if name core main app run debug true line ensures the app runs in debug mode if the script is executed directly. Template rendering. Template rendering is the process of combining a template with a data context to produce an output, frequently HTML. A Ginger2 template object is created from a string containing placeholders. The render function is called with a context, a dictionary mapping placeholder names to values, to produce a string where placeholders are replaced with corresponding context values. Working with forms. Flask is a web framework for Python that provides tools, libraries, and technologies to build a web application. One common feature of web applications is the ability to handle user input through forms. Flask, combined with WT Forms, simplifies form handling and validation. This code snippet shows a basic setup for handling a login form in a Flask application. We define a login form class with WT Forms, which contains validators to ensure that the username and password are of appropriate length. The Flask route/login renders a template with the form on GET requests. Upon POST requests, it checks if the form is valid. If so, it proceeds with the login process, e.g., checking credentials. Note that login.html needs to contain the HTML form that corresponds to the login form fields. HTTP methods. In the context of a client-server architecture, HTTP, Hypertransfer Protocol, methods are used by clients to indicate the desired action to be performed on a given resource. Each method has a distinct purpose and semantics. The most commonly used HTTP methods are get, post, put, delete, and patch. The code snippet defines an API using Flask, a web framework in Python. It illustrates handling 4 different HTTP methods at the same route/resource. The get method is used to retrieve data from the server. In this code, when the client sends a get request to /resource, the getResource function will be invoked and returns a simple response. The post method is used to send new data to the server. Here, createResource function will be called upon a post request to create new entries. Put is used to update existing data. Accordingly, the updateResource function processes the put request to update resources. Delete method allows clients to delete resources. The deleteResource function handles such requests. RESTful API development. A RESTful API, or Representational State Transfer API, is an architectural style for creating web services. It allows for interaction with RESTful web services using HTTP requests to perform CRUD operations: create, read, update, delete. Libraries like Flask in Python make it easy to develop RESTful APIs. The code is a simple Flask application defining a RESTful API endpoint /items. It uses the Flask framework to set up a web server. When a client sends a GET request to /items, the server responds with a list of items in JSON format. The decorator app.route establishes the route, and methods defines that it accepts GET requests. The function getItems is mapped to this route and returns the list of items serialized as JSON. Running this server and accessing the endpoint would yield the items data. Flask extensions. Flask is a micro-web framework for Python. It is designed to be simple and easy to use, but sometimes you may need additional functionality that is not provided out of the box. Flask extensions are packages that add this extra functionality to Flask applications. Some popular extensions include Flask SQL Alchemy for database interactions, Flask WTF for form handling, and Flask Migrate for database migrations. The code snippet shows how to use the Flask SQL Alchemy extension within a Flask application. It starts by importing Flask and the SQL Alchemy class from Flask SQL Alchemy. The application object is created, and the database URI is configured. Next, the database object is instantiated, creating a connection to the database. A user model is then defined using SQL Alchemy, which will map to a table in the database. Each attribute of the user class corresponds to a column in the database table. The WebRepr method provides a readable representation of the user instances. Django overview. Django is a high-level Python web framework that encourages rapid development and clean, pragmatic design. It is built by experienced developers to take care of much of the hassle of web development, so you can focus on writing your app without needing to reinvent the wheel. It's free and open source. Django follows the batteries included philosophy and provides almost everything developers might want to do with a web application out of the box. It includes an ORM, Object Relational Mapper, to deal with database operations, a URL routing system, an authentication system, and an admin interface for managing the content of your website, along with many other tools. A Django project consists of a collection of applications that are made to perform a particular function, promoting modularity and reuse. Efficient, secure, and scalable, Django has become a popular choice for developing complex web applications. Model View Template MVT Pattern. The Model View Template MVT pattern is a variation of the MVC, Model View Controller pattern, commonly used in the Django web framework. The model defines the data structure, view handles the business logic, and template is responsible for presentation. The flow starts with a URL mapping to a view. The view interacts with the model and renders a template. Although there's no specific code for the MVT pattern itself, as it's a design concept, you would generally see a Django project with separate files for each part of the pattern. Models.py, defining database schema, views.py, handling requests and business logic, urls.py, URL dispatcher, and templates, folder containing HTML files. The views use the models to interact with the database and populate the templates, which are then rendered to the user. Introduction to Pandas. Pandas is a powerful Python library for data manipulation and analysis. It provides fast, flexible, and expressive data structures designed to work with relational or labeled data, both easy and intuitive. The primary objects in pandas are the data frame and the series. The code snippet imports the pandas library and aliases it as PD for ease of use. A dictionary of data with two keys, name and age, is created, representing columns of a table. Then, this dictionary is passed to the PD dataframe constructor to create a dataframe object. The dataframe is essentially a table with rows and columns, similar to an Excel spreadsheet or SQL table. Finally, the dataframe is printed, displaying the data in a structured format. Series and data frames. In pandas, a series is a one-dimensional array-like object that can hold data of any type, integers, strings, floats, Python objects, etc., and it has an associated array of data labels, called its index. The code snippet imports pandas and creates a pandas series from a list of integers. The series is then printed to the console. Series are similar to arrays in Python, but have an index that can be used to access and manipulate the data. Data cleaning. Data cleaning is the process of identifying and correcting, or removing, errors and inconsistencies in data to improve its quality. This task can include handling missing data, removing duplicates, correcting typo errors, standardizing data entries, and much more to ensure that subsequent data processing yields accurate and actionable insights. The given code snippet demonstrates basic data cleaning techniques using pandas, a Python library for data manipulation and analysis. First, we create a sample data frame with potential data issues, such as missing values and duplicates. We then use fillNar to replace all nan missing values with the word missing. Alternatively, we can drop rows containing missing values with dropNar. Furthermore, drop duplicates removes duplicate rows. Note that, by default, drop duplicates considers all columns. Finally, the cleaned data is saved to a CSV file with toCSV, excluding the index column with index equals false. Data aggregation and grouping. In Python, particularly with pandas, data aggregation and grouping are powerful techniques for summarizing and analyzing data. Grouping allows you to categorize data based on a given key, and then perform operations on these categories. Aggregation refers to any data transformation that produces scalar values from arrays, such as sum, mean, count, etc. The provided code snippet first imports the pandas library. It then creates a data frame with some sample data that includes a company column, an employee column, and a sales column. Afterwards, it uses the groupBy method to group the data based on the company column. Within this grouping, we use the agg method to apply multiple aggregation functions, sum, mean, and count, on the sales column. The final output will display the total sales, sum, average sales, mean, and the number of occurrences, count, for each company. Working with time series data. Time series data refers to a sequence of values taken at successive, equally spaced points in time. In Python, pandas provides functionality to handle time series data effectively. Let's start by creating a simple time series using pandas. The provided code imports the pandas library and creates a date range starting from January 1st, 2023, with 6 periods, days in this case. A corresponding pandas series is created with the dates as the index and integers as data. Visualization with matplotlib. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. It provides an object-oriented API for embedding plots into applications. The most common way to use it is via its pyplot module, which provides a MATLAB-like interface. The code snippet first imports the matplotlib.pyplot module under the alias plt. It creates a simple list of x and y values to represent the data. By calling pl.subplots, it initializes a figure and a set of axes, which is the area where the data will be plotted. The ax.plotxy function is then called to create a line graph of y versus x. Finally, plt.show displays the figure with the plotted data. Visualization with Seaborn. Seaborn is a powerful Python library that simplifies the creation of beautiful, informative statistical graphics. It's built on top of matplotlib and closely integrated with pandas data structures. Here we introduce a basic plot using Seaborn to visualize a distribution of data. We first import Seaborn and matplotlib's pyplot. Then we load a dataset named tips, which is included in Seaborn's library. This dataset contains information about tips collected from a restaurant. Using sns.histplot, we create a histogram for the total bill column to see its distribution. Finally, pull.show is called to display the plot. Introduction to NumPy. NumPy, which stands for Numerical Python, is a fundamental package for scientific computing in Python. It provides support for arrays, vectors and matrices, along with a collection of mathematical functions to operate on these arrays. NumPy arrays have advantages over Python lists, such as being more compact, faster, and having more convenient and efficient functionality for mathematical operations. The provided code snippet demonstrates the basics of creating a NumPy array. Firstly, the NumPy library is imported with NP as its alias, which is a common convention. Then, we create a simple one-dimensional array using np.array with a Python list. Finally, the array and its type are printed, which will show that R is an instance of numpy.nArray. Array operations. In Python, arrays can be handled by the array module or more commonly by the NumPy library, which provides a powerful array object called endArray. Basic operations on arrays include element-wise addition, subtraction, multiplication, and division. We'll cover these operations using NumPy due to its wide usage in the scientific computing community. The provided code demonstrates basic array operations using NumPy. After importing NumPy as NP, two arrays are created using np.array. Then, element-wise operations are performed. Addition, R1 to R2, subtraction, R1 minus R2, multiplication, R1 to R2, and division, R1 R2. The results are stored in variables result_add, result_sub, result_mul, and result_div respectively. These operations are broadcasted, meaning they are automatically applied to each corresponding element of the arrays. The results are then printed to the console. Broadcasting. Broadcasting in Python, particularly with NumPy arrays, is a powerful feature that allows arrays of different shapes to be used together for operations without explicitly reshaping them. It's accomplished under specific rules that align the shapes of arrays, often involving stretching dimensions with size 1 to match the corresponding dimension of the other array. In the provided code, A is a 1D array with shape 3, and B is a 2D array with shape 3, 1. When adding A to B, broadcasting occurs. NumPy stretches A across the second dimension, which is 1 for B, to match the shape of B. This is like adding 1, 2, 3 to each row of B. The operation results in a 2D array where each element of A is added to the corresponding element of B, yielding a new array with the shape 3, 3. No duplicate copies of the data are made during broadcasting. It's a virtual replication for the operation. Socket programming. Socket programming is used in networking to enable communication between two machines over a network. A socket is an endpoint for sending and receiving messages in a network. It is a combination of an IP address and a port number. Python has a socket library that provides a way to set up client and server which can communicate with each other. The provided code snippet demonstrates the basic client side of a socket connection in Python using the socket library. First, it imports the socket module. Then, it creates a socket object with IPv4, AF INET, and TCP protocol, SOC stream. We define a port number to connect to, which the server is also using. Using the connect method, the client connects to the server, assuming the server is running on the same machine. 127.0.1 is the local host IP address. After establishing a connection, it waits to receive data from the server. Upon receiving the data, it prints it out, and then closes the connection with the server using the close method. Creating a TCP/IP server. A TCP/IP server listens for connections from TCP/IP clients and exchanges data with them. Creating one in Python involves using the socket library to establish a socket, bind it to an address and port, and then listen for incoming connections. The code begins by importing the socket module required to create sockets. A socket object is then created using socket AF INET for IPv4 and socket.socstream for TCP. We identify the host's name and select a port number to listen on. The bind method associates the socket with the server's address and port. With listen5, we set up and limit the queue to 5 connection requests. In the infinite loop, accept waits for an incoming connection. When a client connects, a new socket is created for communication with that client, sending them a thank you message before closing the connection. Creating a TCP/IP client. A TCP/IP client in Python can be created using the socket library. This client can connect to a server listening on a specific IP address and port, send messages, and receive responses. The code creates a TCP/IP client that connects to a server at localhost on port 12345. The socket library is used to create a socket object with IPv4 addressing, AF-GOT-INET, and TCP as the transport protocol, SOC stream. The client socket then attempts to connect to the server using its connect method. A message is sent using the sendAll function after encoding it to bytes. It then waits to receive the entire message from the server in a while loop, receiving up to 16 bytes at a time. The client prints the data as it's received and finally closes the socket. Sending and receiving data. In Python, the socket module is used for network communication. To send data from one machine to another, we first create a socket, connect to the host, and then use sendAll or send to transmit data. This code creates a client socket and connects to localhost on port 12345. It sends the message "Hello World" to the server, which needs to be running and listening on the same port. The message is encoded to bytes before being sent, and after the send operation, the socket is safely closed. Working with HTTP. In Python, you can use the requests library to send HTTP requests. Here we'll send a GET request to retrieve data from a web server. The code imports the requests library, which is used for making HTTP requests. We then send a GET request to the specified URL. The response from the server is stored in the response object. We print the status code to verify the request was successful. 200 means success. Finally, we print the JSON content of the response. Building a web crawler. A web crawler, also known as a spider or spiderbot, is typically used to browse the World Wide Web in a methodical, automated manner. This Python example demonstrates how to create a simple crawler using the requests library to make HTTP requests and Beautiful Soup from BS4 to parse HTML content. The script starts by importing the required modules, requests to make web requests, and Beautiful Soup to parse the HTML. It sets the URL variable to the web page to crawl. The request.get method retrieves the HTML content of the page, which is then parsed by Beautiful Soup using the HTML.parser. The findAll method of the Beautiful Soup object is used to find all A tags, which are typically hyperlinks. The href attribute of each link is printed, which represents the crawled URLs. Working with the OS module. The OS module in Python provides a way of using operating system-dependent functionality. It enables you to interface with the underlying operating system in several different ways. In this code, we first import the OS module. Then we use os.getCwd to get the current working directory where the Python script is executed. The result is stored in the variable current_dir and printed to the console. Executing shell commands. In Python, you can execute shell commands using the subprocess module, which allows you to spawn new processes, connect to their input-output error pipes, and obtain their return codes. The subprocess.run function is used to execute the specified command, ls-l in this case. The stdout equals subprocess.pygument captures the output of the command in a pipe, which can be accessed using result.stdout. The text equals true argument indicates that the output is expected to be a string rather than a bytes object. The code prints the list of files in the current directory, emulating the ls-l shell command. File system navigation. In Python, OS and os.path modules provide functions to navigate and manage the file system. We perform tasks like changing the directory, listing contents of a directory, and checking the existence of files directories. The script starts by importing the OS module, which provides access to operating system functionality. With os.getSig, we get the current working directory. os.listdir lists all entries in the current directory represented by. Finally, os.chdr changes the current directory to the specified path. Automating file system operations. Reading files is a common file system operation. Python's built-in open function is frequently used for this task. Here we'll read the entire content of a file. The code opens example.txt in read mode, R. It uses a context manager, the with statement, ensuring the file is properly closed after its block is executed. File.read reads the entire file content into the variable content. Finally, the content is printed. Cron jobs and task scheduling. Cron jobs are scheduled tasks that run at predefined times or intervals on the server. They are typically used for routine background tasks like sending out email notifications, running system maintenance, or backups. Task scheduling is a broader category, which cron jobs fall under, and it can also include scheduling jobs within an application, not just at the system level. The provided code uses the schedule library in Python to define a simple task scheduling routine. The job function is defined to print a message indicating the execution of the scheduled task. The schedule.every day e1030.do job line sets this job to run daily at 10:30 a.m. The while true loop and schedule.runPending call check for any scheduled tasks that need to run according to the schedule, with a 1-second sleep interval to wait between checks. Passing command line arguments. In Python, command line arguments are parameters given to a program when it's invoked from a command line interface. These arguments can control the program behavior or provide input data. Python provides the argparse module to ease the passing of command line arguments. With argparse, you can define the options your program accepts, validate input, and automatically generate help messages. The provided code snippet is an example of using the argparse module to pass command line arguments. First, an argument parser object is created with a description that appears in the program's help output. The addArgument method is used to specify which command line options the program is willing to accept. In this example, integers is a positional argument, and NashSum is an optional argument. When the program runs, args equals parser.parseArgs passes the arguments, with the passed arguments becoming accessible as attributes of the args namespace. Args.accumulate, args.integers will either sum the integers or find the max based on if -sum option is included. Environment variables. Environment variables are key value pairs that can affect how running processes will behave on a computer. They're used to pass configuration information into programs. In Python, you can access and manipulate these variables through the os module. Let's explore how to use environmental variables in Python. We import the os module to interact with the operating system. os.getEnv_home retrieves the value of the environment variable home, which typically stores the path to the current user's home directory. If the environment variable does not exist, getEnv returns none. On setting an environment variable using os.environ testvar equals 1234, we assign a new environment variable testvar with the value 1234. Then we retrieve it with os.getEnv testvar, which will output 1234. Note that changes to environment variables through os.environ affect the current process and its children, not the system-wide environment. Machine learning overview. Machine learning is a subset of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. It revolves around creating algorithms that can process input data and use statistical analysis to predict an output while updating outputs as new data becomes available. The provided code represents a simple example of a machine learning task using the Python library sklearn. It involves the following steps. 1. Loading a standard dataset called iris. 2. Splitting the dataset into a training set and a test set. 3. Creating a machine learning model, here a random forest classifier. 4. Training the model on the training set. 5. Predicting the responses for the test set. This workflow is common in supervised learning tasks, where the goal is to predict an output from given inputs. Scikit-learn basics. Scikit-learn is a powerful Python library for machine learning that provides simple and efficient tools for data mining and data analysis. It is built on NumPy, SciPy, and Matplotlib, and it offers various tools for model fitting, data preprocessing, classification, regression, clustering, dimensionality reduction, and more. The code demonstrates a basic workflow in scikit-learn for a classification problem using the k-nearest neighbors algorithm. The process starts by importing necessary modules and loading a dataset, in this case, the iris dataset. The data is then split into training and testing sets. Next, we create an instance of the k-neighbors classifier, train the model on the training data, and then make predictions on the test data. Finally, the accuracy of the model is calculated by comparing the predicted labels with the true labels of the test set, showing the model's performance. Training a model. Training a model in machine learning involves using a dataset to teach a model how to make predictions or decisions. In the context of Python, libraries like scikit-learn are often used to create and train models. Below, we'll see a simple example using scikit-learn to train a linear regression model on a dataset. The code imports necessary modules from scikit-learn and creates a simple dataset X features and Y target values. It splits the dataset into training and testing sets with train-test split. A linear regression model is created and trained fitted on the training data using the fit method. After training, the model's performance is evaluated on the test data using predict, and the mean squared error, MSE, is calculated to quantify the prediction error. Model evaluation. Model evaluation involves assessing the performance of a machine learning model. Key metrics for evaluation depend on the type of model, such as classification or regression. For classification, common metrics include accuracy, precision, recall, F1 score, and the confusion matrix. For regression, we often look at mean squared error, MSE, mean absolute error, MAE, and R-squared. Below is an example of evaluating a classification model using accuracy and a confusion matrix in Python. The provided code imports two functions, accuracy score and confusion matrix, from the scikit-learn metrics module. It defines two lists, yTrue containing true labels and yPred containing the predicted labels by a model. The accuracy score function computes the accuracy of the model's predictions, which is the proportion of correct predictions over all predictions. The confusion matrix function creates a matrix that indicates the number of correct and incorrect predictions for each class. These metrics provide a basic understanding of the model's performance. Data preprocessing. In real-world datasets, it's common to have missing values. Missing data can be dealt with in various ways, such as dropping those rows or columns, or imputing them with statistical measures like mean, median, or mode. Pandas library in Python offers functions like dropNar and fillNar to handle missing values. The code snippet illustrates two common strategies for handling missing data. 1. Dropping rows with missing values using df.dropNar, which removes any row with at least one NaN value. And 2. Filling missing values using df.fillNar with the column's mean, which calculates the mean of each numeric column and replaces NaN with it. Note that df.mean automatically ignores NaN while computing the mean. Feature engineering. Feature engineering is the process of using domain knowledge to extract features from raw data via data mining techniques. These features can be used to improve the performance of machine learning algorithms. It often involves transforming, normalizing, encoding, and creating new features to provide the learning algorithms with structured, relevant data that captures the essence of the dataset for predictive modeling. In this code snippet, we perform two common feature engineering techniques on a sample dataset, scaling and binning. The dataset consists of ages and salaries. First, the age feature is scaled using min-max scaler from scikit-learn, mapping the age values to a range between 0 and 1. This is beneficial when algorithms are sensitive to the scale of the data. Then, we create an age binned feature by splitting the age feature into discrete intervals, or bins. This technique can be useful to transform a continuous variable into a categorical one, which might be easier for certain machine learning models to handle. Clustering. Clustering is a machine learning technique used to group similar data points together without prior knowledge of the group labels. This technique is useful for exploratory data analysis to find inherent structures. In Python, a popular library for clustering is scikit-learn, which provides various clustering algorithms, including k-means. The code demonstrates how to use the k-means clustering algorithm from scikit-learn. First, we import k-means and NumPy. We create a sample dataset X with 6 data points. K-means is then initialized with 2 clusters and a random state for reproducibility. We use the .fit method with our data X to perform clustering. The .predict method assigns each data point in X to one of the 2 clusters, returning their labels. The cluster centers are stored in centroids, which represent the mean of the points in each cluster.
So it is currently retrying. Let's see. This happened one time before. OpenAI is returning an error. So it'll be interesting to see. It recuperated the first time. So this stuff happens due to API not responding. So in this kind of situations, I wait and retry 3 times. So I'm still thinking what might be a better way in handling this.
Classification.
Oh, there we go.
Classification in Python
So
often
good.
involves
It was
using
able to
libraries
recuperate.
such as scikit-learn to create models that can categorize data into predefined labels. It is a form of supervised learning, where the algorithm learns from a dataset which has labels associated with it. A common task is email spam detection, where emails are classified as spam or not spam based on their content. The code uses the scikit-learn
We're almost
library
at the
to
end.
classify iris flowers into species. It loads a predefined dataset, splits it into training and test sets, creates a k-nearest neighbors classifier, fits the model to the training data, makes predictions on the test data, and calculates the accuracy of the model. The accuracy represents the proportion of correct predictions from all predictions made.
We are at classification. So we're at the end. Regression and then introduction
Python,
to TensorFlow.
regression is a statistical method that models the relationship between a dependent variable and one or more independent variables. Here we'll use one of the most common types of regression, linear regression. We'll employ the scikit-learn
Thank you for
library,
watching.
which provides a simple and efficient tool for data mining
This
and
is
data
available
analysis.
at my Patreon shop.
The code snippet above
Currently for
demonstrates a
$200.
basic implementation of linear regression. It imports necessary modules from scikit-learn and NumPy. After defining sample data x, independent variable, and y, dependent variable, it splits these into training and test sets using train-test-score-split. The linear regression model is then initialized and fitted to the training data with fit. Predictions are made on the test data with predict, and the performance is evaluated with mean squared error to find the MSE, giving an indication of how well the model has learned to predict the dependent variable. Introduction to TensorFlow and Keras. TensorFlow is an open-source machine learning library developed by Google, and Keras is a high-level neural networks API that can run on top of TensorFlow. It simplifies the process of constructing, training, and deploying machine learning models. The code snippet starts by importing TensorFlow and the Keras API from TensorFlow. A simple model is defined using the sequential class from Keras with one dense layer that has a single unit and expects an input shape with a dimension of 1. The model is compiled using the stochastic gradient descent (SGD) optimizer and mean squared error loss function, which are standard choices for regression problems. Finally, the model is trained using a set of example data xs and ys for 10 epochs, where it learns to predict the output from the given input.
So this is it. This is the end. So this took about 2 hours and 12 minutes to go over the entire Python course. It could have been longer or shorter. I'll make more streams such as this. If you like Auto Streamer, I have it available at my Patreon. It's currently for $200. It's at the shop. Link is in the description. And this is about it. If you like my content, you can visit my website at echohive.live and find all my videos. I have over 240 actually. This is currently, I have to update the website. Also check out CodeHive. Here you'll find over 900 GPT-powered Python chat applications. You can just copy the code into your IDE and run it. You can also download all of them, again, at my Patreon. This is available for $100. But yeah, so this was exciting. New project for me to do in starting 2024. I'll just stop this. Thank you for watching, and I'll see you in the